Addition does not mean to increase. Subtraction does not mean to remove. What then do they mean? That takes us to the second lesson objective of this topic, that is meanings of basic number operations. Please sit back and cooperate with me as I explain the meanings of addition, subtraction, multiplication, and division. Please listen. Yes, objective number two, meanings of basic number operations. In the previous objective, that is section, we are told towards the end of that section that there were four basic number operations in early accounting. They included addition, subtraction, multiplication, and division. In this section, let us learn what each of these four basic operations means. To start with, we mention addition. What does it mean? Let us find out. To add means to combine. Therefore, addition means combination. Before now, what did you think was the meaning of this word addition? Perhaps you have been thinking that to add means to increase. Not necessarily. Sometimes, after adding something to something, the result might be an increase. But sometimes, after adding things together, the result might even be a decrease. Therefore, it is not the final result that gives this word its meaning. Addition does not depend on the final result of the process. Instead, the process of combining numbers of things together is what is called addition. It is not the result of the process. When addition was first started in early accounting, it was invented to add only what somebody had. Owing somebody something came later, but having things came earlier. Addition had been invented before owing things started or came into existence. Therefore, traditionally, addition was meant to be combining only the things that were had. It was meant to be combination of only things that people possessed, not the ones that they owed people. Let us illustrate with a simple example. The example said plus 5 plus 7. The brackets are helping us to achieve a particular goal. This plus that precedes 5 tells us that this 5 is what we have, or what you have. This plus before the 7 tells us that this 7 is what you have. And now, this plus, for now, can represent the process of combining. That is, I have 5, I have 7, combine them. This bracketed expression can be written in a simpler way. See it here, 5 plus 7. In this case, 5, which is here, no longer has a sign before it. But as you may have learned earlier, whenever a number is written without a sign before it, the sign before it is plus. Therefore, this is an example of addition. Notice that both things that were added were things possessed, not things that were owed. Like I said earlier, addition was invented when what was in vogue was just having. What about when liabilities began to come? Let us find out with the next type of number operation, that is subtraction. Let's see. And that takes us to number B, that is the meaning of subtraction. already you can see that to subtract means to add or include what we owe. Before now, what did you think is the meaning of this word subtraction? Did you think that it meant to remove or to reduce? Anyway, with examples that follow, you might now find out that that idea about subtraction, that is removing, is wrong. It does not mean to remove. It does not mean to decrease. Sometimes after we add what we owe, it might still lead to something that is not owing. What then is subtraction? It is not the end of the process that determines whether it is subtraction or not. It is not whether the last answer is owing or having that determines whether we are carrying out subtraction or not. Instead, it is the process of adding or including what we owe. Therefore, subtraction means addition of liabilities. Don't forget that I said earlier that when addition was invented, that it was adding only what we had or what they had that was in vogue. Gradually, people began to borrow, and consequently, they began to owe people. That was a time to invent a second number operation, that is subtraction. And today, we learn it as addition of liabilities, that is bringing what you owe to join with anything else. Sometimes when you add liabilities, you add them to other liabilities. And sometimes when you add liabilities, you add them to assets. So whether we are adding liabilities to liabilities or adding them to assets, addition of liabilities is what is called subtraction. Let us illustrate with a simple example. The example is here, plus 5 plus minus 7. This is a bracketed number operation in simple accounting. Here, we are simply adding what we have to what we owe. Which one is subtraction? It is the process of adding this thing we are owing, which is 7. Whatever had been here before is not important to us. What is important is that we are adding what we owe. The process of adding what we owe is called subtraction. Now, we are adding 7, which we owe. Whether what is here is what you are owing, which is owing 5, or what you have, which is having 5, as you can see in the bracket, we're not concerned. We are simply asking ourselves, are we subtracting? If the answer is yes, what is it? We are adding what we are owing. Don't forget that owing came after having the sense of having. That is the history of today's mathematics or early accounting. Now, since this is example of subtraction, the entire thing is not subtraction, but this section is called subtraction. Whatever exists here is immaterial. We can also simplify this process to be this. That is having 5, owing 7, minus 7. This addition can take place in our mind. It means that many times we don't include addition of something in our written expressions. Instead, at all times, they exist in our mind. That is, additions of the things that we have or owe exist in our mind, and we carry them out in our minds. Therefore, this minus 7 is still what is here, but that plus has disappeared. Where has it gone to? In a new section that comes later, we're going to explain what happened to this plus. But for now, just know it that the most important thing is that we have added this 7 which we owe to 5 that we had. Our intention in this section is not to give an answer to this number operation, though we can tell that the answer will be -2. That is not exactly what we're concerned with at this point. If you had been thinking earlier that subtraction is reducing or removing something from something, just tell me 5 minus 7 is a correct number operation. But if you have been thinking that subtraction means removing, how can somebody remove 7 from 5? Is it possible? If not possible, it means that you should consider giving a new meaning to subtraction, not the one you had earlier. The meaning of subtraction is not reduction or removal. It means to add what we owe. Can somebody repeatedly have? Yes. Can somebody also repeatedly owe? It is also yes. That takes us to the third number operation, that is multiplication. Let's see. As you can see, we turn to the third number operation, that is multiplication. What does it mean to multiply? To multiply means to add the same number. We have learned earlier that to add means to combine. So if we are adding numbers, it thinks that we are combining numbers. We can combine 5 and 7. That one is not multiplication because the numbers we are combining are not the same. If we combine 7 and 12, we are combining numbers actually, but that is also not multiplication. Why? That is a combination of different numbers. But if we keep combining the same number repeatedly, that is what we refer to as multiplication. So if the same number features in addition of numbers, whether it is what we are owing or what we are having, that features in the repeated addition of numbers, that process is what we refer to as multiplication of numbers. Therefore, multiplication is a repeated addition. Let us use a simple example to illustrate this so that we can clearly grasp the concept of multiplication. Let's see. Let's use 2 examples instead to illustrate the concept of multiplication. Look at the first example, 5 plus 5 plus 5 plus 5. For convenience, it is written just as 5 times 4. This tells us how many times this 5 were brought. The 4 tells us how many times. 4 is how many times, and this simply means the times itself. Therefore, for convenience, this operation is written like this. It saves more space, it saves more energy, it saves more time to write this in this form. Do you observe that this is a kind of addition that involves the same number? That is, are you seeing it as a repeated addition of the same number? Yes, you should. Why? Because the same 5 features everywhere. If different numbers had been appearing here, 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 and here, then we would have referred this not to as multiplication. But because the same number 5 appears, we could call it multiplication. So we are multiplying 5. To multiply 5 means to keep increasing something by 5 each time, or let the same 5 be added to 5 each time, depending on how many times the person carrying it out wants. The main thing is that the same number 5 is being added to itself. So when a number is repeatedly added to itself, that number is said to be multiplying. Therefore, here, 5 is multiplying. What if it is something like 7 multiplying? It will be 7 plus 7 plus 7 plus 7 to a number of times that 7 is required to multiply itself. Don't forget that this is written also in this form for convenience. Here, it is what we have that is multiplying. What it means is that it is 5 that we have that we are adding to itself. That means we have 5, we have 5, we have 5, we have 5. We don't have interest in what the result turns out to be. Our interest is in this repeated addition of the same number. In contrast, here in example 2, we are focusing on the same 5, but this time around, we are owing the 5. We don't have it. That is why it reads minus 5, minus 5, minus 5, minus 5. That is, keep adding owing 5 to itself. That is, I'm owing 5, I'm owing 5, I'm owing 5, I'm owing 5. For convenience, this owing 5 that appears 4 times is written like this. That is minus 5 times 4. Whether it is in this first example or this second example, something has become clear. What is it? Look at this sign. It is common to both of them. What it means is that this sign is a simpler sign that replaces this sign, which is repeated addition. If you keep on adding by writing this, if you keep on adding and writing this plus, plus, plus to anywhere as required, it takes space, it takes time, it takes energy. To prevent that from happening, we just use a simple symbol. See it here. So wherever you see this type of symbol, it refers to addition of the same number. And it has a name. What is it? Multiplication. Again, to multiply means to add the same number. We call it repeated addition of the same number. That is what? Multiplication. That takes us to the last of the number operations, the 4 basic number operations used in the early accounting, and that one is division. Let's find out. And now the 4th number operation, and that is division. What does it mean? To divide means to break into equal pieces or equal portions. Note this word equal. If you break things into portions, but those portions are not equal, that is not called division. We're going to use an example that will help us bring to life this meaning of dividing something or breaking something into equal portions. With that example, we get 2 other meanings of this division. Altogether, we're going to get 3 different meanings for division. Let us see the example. Now, see the example. It says 10 divided by 2 or 10 over 2. What does it mean? Like I said earlier, it means the following things. 1, it means 10 broken into 2 equal portions. Again, take note of this word equal. The 2 here tells us how many times we're going to break this 10. It means break this 10 into 2 equal portions. That is what this 10 over 2 means. That is one of its meanings. The second meaning is how many 2's that make 10. It means these 2 here, how many of it will give us this 10? Don't tell the answer. We know it is 5. But the answer is not what we are concerned with right now. It is the meaning of this expression. In later operations, you'll be concerned with giving answers by means of interpretation. We are simply interpreting this expression. So far, we have taken 2 meanings of this expression. Again, the first one is 10 broken into two equal portions. And second one is how many 2's that make 10. The third meaning of this 10 over 2 is how many times 2 can be removed from 10. What it means is this. If you will start removing 2 from this 10, how many times are we going to carry that removal out before 10 is exhausted? Let us check whether these three meanings will give the same answer afterwards. Let's start with the first one. But why are we looking at the answer? If after interpreting the three meanings and giving the answers, and they give us different answers, it thinks that these meanings do not refer to the same expression. But if at the end we get the same answer for all the three meanings, what it means is that the three meanings are valid. Let us start with the first one, that is 10 broken into two equal portions. If 10 is broken into two equal portions, what is the answer? The same 5. If we say how many 2's that make 10, please, how many 2's make 10? 5 again. The third one says, how many times can 2 be removed from 10? Let's do it. When this 10 is written, we say minus 2. What remains there? 8. Minus 2. What remains there? 6. Minus 2. What remains there? 4. Minus 2. What remains there? 2. Minus 2. And what remains? 0. Now in the end, how many times did we remove these 2 from 10 before 10 got exhausted? How many times? 1, 2, 3, 4, 5. Therefore, when this is interpreted, the answer is 5. This also gave us 5. And now, this also has given us 5. What it means is that these three meanings are valid. Now I ask, will these meanings of these 4 basic number operations change with time? The answer is no. Whenever something is found to be mathematically correct, it remains correct to times indefinite. Number operations do not change with time. We can only find better ways of carrying out number operations. That does not mean that the former operation we were used to has become incorrect. It simply means that we have a faster way of carrying out the same operation. Now, if we see more complex operations in future involving addition, subtraction, multiplication, and division, we should not be afraid to start with these basic interpretations so that by the time we are through with interpretation, then that which appears complex will become simple, and eventually the answer can come out without much stress. That is one way to make mathematics easy. Again, don't forget that these basic operations remain. They're always true and valid.